limit x tends to 0, 1 plus x to the power 1 by x can be written as e. When x is not equal to 0, limit as x tends to 0, e power 2x minus 1 divided by x we have. Limit as x tends to a, x to the power n minus a to the power n divided by x minus a, which can be written as n into a power n minus 1. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. We are at the revision session of chapter-wise question and answer. In today's session, I'll be taking the revision questions on the chapter Limits and Continuity. So, in the chapter Limits and Continuity, you may expect 1 mark question, 2 mark question, 6 mark question. Let's see the distribution of marks from this chapter. So, from the chapter Limits and Continuity of a function, you will be having 1 1-mark question, 1 2-mark question and 1 6-mark question. So, totally you will get 9 marks from this chapter Limits and Continuity. So, let's see 1-mark question. So, for 1-mark question, you will get evaluation of limits either trigonometric, algebraic or using the standard result. So, the first one is evaluate limit sin ax by bx where a and b are non-zero constants. So, we know the theorem that is limit theta tends to 0, sin theta by theta is equal to 1. So, whenever it is in the form of sin theta by theta as limit theta tends to 0, we can express this as 1. But here we have ax. In the denominator, I need ax, but I have bx. So, to make it common, I will take limit x tends to 0, sin ax divided by bx. What I will do here is, I will multiply a and divide it by a. Then I can write this as, here I can take a as a constant, I will take out. From the denominator, I will take b as a constant. So, I will get a by b. Now, I will get limit as x tends to 0 sin ax divided by a into x is ax. Now, this is in the form of sin theta by theta whose value I can take it as 1. So, therefore, a by b into 1 is equal to a by b. So, this is the limit of the given function. Next one. Limit x tends to 0, 1 plus 3x whole to the power 1 by x. We have to find the value. We know the standard limit, that is limit x tends to 0, 1 plus x to the power 1 by x can be written as e. So, here I have 3 there in the place of x. So, what I will do here, I will consider this limit x tends to 0, 1 plus 1 by x. Here, I will multiply 3 and divide it by 3. So, now here, I can write this as limit x tends to 0, 1 plus 3x to the power 1 by 3x whole to the power 3. So, here, I can take 1 plus 3x 1 by 3x in the form of 1 plus x 1 by x, which can be written as e. Hence, I can write this as e cube. So, this is the value of the limit. Next one, limit x tends to 3, x square minus 4x divided by x minus 2. Directly you can apply the value of the limit as x is equal to 3. I get 3 square minus 4 into 3 divided by 3 minus 2, which is equal to 9 minus 12 divided by 1, that is equal to minus 3. The value of the limit is minus 3. Next one. Evaluate limit sin 4x by sin 2x as x tends to 0. So, here I have to consider this in the form of sin theta by theta. So, to make it in the form of sin theta by theta, I will divide both the numerator and denominator by 4x. So, then it will be in the form of sin 4x divided by 4x, and the denominator I will take it as sin 2x divided by 4x I have to divide. I'll write it in the form of 2 into 2x, which is nothing but 4x only. Now you can apply the limit. So here you can apply the limit separately. Limit as x tends to 0, sin 4x by 4x whole divided by, here I can take 2 constant, then I'll get 1 by 2, limit as x tends to 0, sin 2x divided by 2x. So after dividing by 4x, we can apply the limit for the both numerator and denominator separately. Here 2 is a constant which is in the form of 1 by 2. So I will take it out. Now the value of this limit is equal to 1 and the value of this limit is equal to 1 because it is in the form of sin theta by theta as theta tends to 0. So therefore, I can write it in the form of 1 by 2 which can be written as 2. So the value of this limit is equal to 2. 1 by 2 can be taken to the numerator in the form of 2. Next one, evaluate limit x tends to minus 3 x cube plus 27 divided by x plus 3. We know that limit as x tends to a, x to the power n minus a to the power n divided by x minus a can be written as n into a to the power n minus 1. So, comparing or writing this in the form of this limit, you can write this as limit as x tends to minus 3, x cube minus 3 whole cube divided by x minus of minus 3. So here comparing these two equations, this is in the form of x to the power n minus a power n by x minus a, where the value of a is minus 3, the value of n is also 3. Now n into a power n minus 1 becomes 3 into minus 3 to the power 3 minus 1, which is 3 into minus 3 whole square. So 3 3s are 9, 9 3s are 27. So the value of the limit is 27. So these are few questions which is a simple evaluation of limits you can expect. Now we will move on for 2-mark question. So the 2-mark question, most probably they will give you the problems on continuity of a function. That is whether they'll ask you to show that the given function is continuous at particular point, or they will ask you to find the value of k in the given function whenever it is continuous at particular point. So these two type of question they may ask you for 2 marks question. So here find k if the function f of x e to the power 2x minus 1 by x is whenever it is not equal to 0, and k if x is equal to 0 is continuous at x is equal to 0. Now we know the standard limit, that is limit as x tends to 0 e power ax minus 1 divided by ax. So can be taken in the value of 1. So here if x is not equal to 0, I can write here, so when x is not equal to 0, limit as x tends to 0 e power 2x minus 1 divided by x we have. So to get this in the form of this, in the place of a I have 2x, but in the denominator I don't have 2x. So for that I will multiply 2 and divide by 2. So then I'll get in this form. So when you apply the limit for this function, limit x tends to 0 e power 2x minus 1 divided by 2x is 1, and for constant it is constant itself. So we get the value is equal to 2. Now they have given the function is continuous at x is equal to 0. So since the function is continuous at x is equal to 0, since f of x is continuous at x is equal to 0, I can write limit as x tends to 0, f of x is equal to f of 0. So when f is equal to 0, the value is equal to k. And limit of the function is equal to 2. So therefore, the value of k is 2. Next question. Find k if the function x to the power 4 minus 256 divided by x minus 4, x not equal to 4, and k when x is equal to 4 is continuous at x is equal to 4. So first let us apply the limit for this function. So limit as x tends to 4, x power 4 minus 256 divided by x minus 4. So this is in the form of limit as x tends to a, x to the power n minus a to the power n divided by x minus a, which can be written as n into a power n minus 1. Now here, so if you apply this limit in this form, I can write this as n limit x tends to 4, x power 4 minus 4 power 4 divided by x minus 4. So this can be written as n into a power n minus 1 means 4 into 4 to the power 4 minus 1. So I will get 4 into 4 cube, which is nothing but 4 cube into 4. Again the value is equal to 256. Now they have given the function is continuous at x is equal to 4. Since f of x is continuous at x is equal to 4, what I can write is limit as x tends to 4, f of x is equal to f of 4. Now at x is equal to 4, the function value is equal to k. Now as x tends to 4, the limit value is equal to 256. So therefore, the value of k is 256. Next one, find k if the function f of x is equal to k plus x at x is equal to 1, 4x plus 3 when x is not equal to 1. So given at f of 1, the function is equal to k plus x. Now let us apply the limit as x tends to 1 for the function 4x plus 3. When you take x tends to 1, it is 4 plus 3, that is equal to 7. Now given that it is continuous at 1, so f of x is continuous at x is equal to 1. Since the function is continuous at x is equal to 1, I can write limit x tends to 1, f of x is equal to f of 1. So when you apply the limit for the given function, the value is equal to 7, and at f of 1, the value is k plus x. So in the place of k plus 6, I can write k plus 1. So here also I can write it as k plus 1 because the value of x is 1. Now solving this, I get k is equal to 6. Show that the function f of x is equal to 1 plus 3x whole power 1 by x when x is not equal to 0, e cube when x is equal to 0 is continuous at x is equal to 0. To show that the given function is continuous, we have to show that the limit of the function as well as the functional value at the given point is same, that is they are equal. So for that purpose, first I will take f of 0. At x is equal to 0, clearly the functional value is e cube. Now let us apply the limit when x is not equal to 0. That is, we take it as limit x tends to 0. That is, when x is not equal to 0, the function is 1 plus 3x whole to the power 1 by x. We have already solved this. If any function in the form of 1 plus x to the power 1 by x as limit x tends to 0, then the value is equal to e. Now since here in the place of x I have 3x, I will multiply 3 here and divide by 3 here. Now I get this function in the form of 1 plus x 1 by x. So when you apply the limit for this function, the value will be equal to e, and outside we have cube. So the value is equal to e cube. So we have got f of 0 and limit of the function are one and the same. So therefore, limit of the function as x tends to 0 and the functional value at x is equal to 0 is one and the same, that is e cube. So therefore, I can conclude the function is continuous at x is equal to 0. If the limit value cannot be equal to the functional value, then we say it as discontinuous. Since here we are getting the functional value as the limit value one and the same, we can directly say that limit exists and hence it is continuous at the point x is equal to 0. So these questions from the continuity of a function you can expect for 2-mark question. So next we have a 6 marks category question, which is a compulsory question, that is, prove that limit as x tends to a, x to the power n minus a to the power n whole divided by x minus a is equal to n into a to the power n minus 1 for all values of n. So each and every year this question will come for 6 marks question under part E section. So now let's start proving this result. So first consider the expansion of x to the power n minus a to the power n. It can be written as x minus a into, so here we have x to the power n minus 1 plus x to the power n minus 2. So you can use the concept of binomial theorem also here. X to the power n minus a to the power n can be written as x minus a, x to the power n minus 1, x to the power n minus 2a plus x to the power n minus 3a square plus the last term will be a to the power n minus 1. Now divide both sides by x minus a, then the equation become x to the power n minus a to the power n, x minus a is equal to x to the power n minus 1 plus x to the power n minus 2a plus x to the power n minus 3a square plus the last term a to the power n minus 1. Now let us apply the limit as x tends to a on both sides. So if you apply the limit as x tends to a on both sides, then that is x to the power n minus a to the power n x minus a. Apply limit as x tends to a for this function also, then it is x to the power n minus 1, x to the power n minus 2a plus etc. The last term is a to the power n minus 1. Now apply the limit on the right hand side. This becomes a to the power n minus 1 plus a to the power n minus 2a is a to the power n minus 1 again. So a to the power n minus 1 again, and the last term is a to the power n minus 1. So how many terms we have? We have n terms. So therefore this is equal to n into a to the power n minus 1. So this is case 1 for positive integer. Hence we got limit of x to the power n minus a to the power n divided by x minus a as x tends to a is equal to n into a to the power n minus 1. So this is the case for positive integral. Now let us take case 2. So let's take n is equal to minus m. So we are doing it for negative integral. We know it limit as x tends to a, x to the power n minus a to the power n divided by x minus a. So replace the value of n by m. So then this becomes limit as x tends to a, x to the power minus m minus a to the power minus m divided by x minus a. So this can be written as limit x tends to a 1 divided by x power m minus 1 divided by a power m divided by x minus a. Now here I can write this as limit x tends to a power m minus x power m divided by x power m, a power m into x minus a. Now here, so take negative outside, then this becomes limit as x tends to a, and here we have x to the power m minus a to the power m divided by x minus a into 1 divided by x power m, a power m. Now when you apply the limit for this function, this is equal to minus n into a power n, which becomes m into a power m minus 1. And here when you apply this into 1 divided by a to the power m into a to the power m. So I will get minus m, a power m minus 1, m into m I have 2m, so I will get minus 2m, where I get minus m, a to the power m minus 1. Now separate minus m, minus m. So what I got is here limit x tends to a, x to the power minus m minus a to the power minus m divided by x minus a. So what is minus m I have taken? Minus m is nothing but n. So therefore in this case also I will get limit x tends to a, x to the power n minus a to the power n by x minus a is equal to n into a power n minus 1. So this is case 2 for negative integers. Next case, case 3. Suppose n is equal to in the form of p by q, here q is not equal to 0. Now substitute here, what happens if you take n is equal to p by q? This becomes as x tends to 0, x to the power p by q minus a to the power p by q divided by x minus a. Now here we have, it is in the form of x to the power p by q. So let me keep this in the form of limit as x tends to 0, x to the power 1 by q whole power p minus a to the power 1 by q whole power p divided by x minus a. Now let x to the power 1 by q is equal to y and a to the power 1 by q is equal to b. So this is nothing but what? X is equal to y to the power q and a is equal to b to the power q. So now let us substitute it. This is equal to limit x tends to 0. So x to the power 1 by q means y. So y to the power p minus b to the power p whole divided by x is nothing but y to the power q minus a is nothing but b power q. So b to the power q. So now since here I have taken the x value as n tends to 0. So here now I have replaced the variable. Hence I have to take y tends to 0. Now here I will get limit y tends to 0. Here y power p minus b power p divided by y minus b whole divided by y power q minus b power q whole divided by y minus b. If you apply the limit separately for numerator and denominator, I will get it as limit y tends to 0, y to the power p minus b to the power p divided by y minus b whole divided by limit y tends to 0, y power q minus b power q divided by y minus b. Applying the limit, I will get p into b to the power p minus 1 q into b to the power q minus 1, which can be written as p by q, and here I will get q minus 1. So b to the power p minus 1, q minus 1 become minus q plus 1. I can cancel plus 1 minus 1. So here I have left with p by q b to the power p minus q. Now here I will take q as a common factor. Now this is what I get, p by q b to the power p minus q. But what is b? B value is nothing but a to the power 1 by q. So I will replace it with p by q a to the power 1 by q to the power p minus q. Now multiply q inside, it becomes p by q a to the power p by q minus 1. So what is this actually? Limit x tends to 0, x to the power p by q minus a to the power p by q whole divided by x minus a. Now we got this in the form of n into a power n minus 1. So replace it back. So therefore I can conclude limit as x tends to 0, x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. Now since I have taken n is equal to p by q, I will replace back p by q in the form of n. I will get the same result. Hence, in all the three cases, that is for n, that is for positive integers and for negative integers and for the fraction form, I am getting the limit of the function in the form of n into a to the power n minus 1. A very important theorem for 6 marks compulsory question. So one more question under the category of 6 or 5 mark question, that is prove that limit theta tends to 0, sine theta by theta is equal to 1, where theta is in radians. Consider the unit circle. Let me take O as the center, OA be the radius. Now take an angle theta, and angle theta must lie between 0 to pi by 2. That is only in the first quadrant. Let me mark this as point B. Mark a perpendicular line from B as well as a perpendicular to line A. So draw two perpendiculars, one it for the radius OA from the point B and for the point A. So these are the two perpendiculars. Join AB and join these two lines. So let me take this point as C and D. So whatever you are doing the construction, you have to write. So consider the unit circle with center O. Let OA be the radius and theta be the radians between 0 to pi by 2. Now draw two perpendicular BC and AD to the radius OA. Join AB and extend OB to OD. So these are the things you should know. Now from the figure, you can clearly observe that is the area of OAB, triangle OAB. So area of triangle OAB is less than area of sector AOB, and it is strictly less than area of the biggest triangle, that is OAD. Now since OAB is a triangle, I can apply the formula half into base into height. So for the smaller triangle, the base is OA and the height is BC. For the bigger triangle, base is OA and height is AD. And I can use the area of a sector formula. So using that, I can write this as half into OA into BC less than half into OA square into theta less than half into OA into AD. So this is what I will get. Since half is common factor in all, I can remove it, half, half, half. OA is also common factor, so I can remove it. So once you got, you will get BC less than OA into theta less than AD. Let me take this as equation 1. So I will get BC less than OA theta less than AD. Now from the two triangles DOA. So let us apply tan theta. So from triangle AOD, tan theta. So this implies, what is tan theta? Tan theta is opposite side by adjacent side. That is AD is equal to OA. Now tan theta, so OA, that is equal to AD. So let me take this as equation 2. So AD can be written as OA into tan theta. Next, again from the triangle O, B and C, what I can apply? Sin theta. So from triangle BOC, sin theta can be written as opposite side by adjacent. Opposite side by sin theta is equal to opposite side by hypotenuse. So opposite side by hypotenuse. So that is BC divided by OB. Now here OB and OA are one and the same because they are the radius of the circle. Hence in the place of OB, I will write OA. Now I can write BC is equal to OA into sin theta. So let me take this as equation 3. We know equation 1 is BC less than OA theta less than AD. In the place of BC and AD, substitute the given value. So from 1, so in the place of BC, I can write OA sin theta less than OA theta less than, in the place of AD, I can write OA tan theta. Again, I can cancel OA, OA, OA because it is common in all the three inequalities. Now I got sin theta less than tan theta. The next condition is divide by sin theta throughout the condition. So if you divide the sin theta throughout this equation, I'll get sin theta by sin theta is 1, and here it becomes theta by sin theta. Tan theta by sin theta becomes 1 by cos theta. Now again taking reciprocal, I will get cos theta less than sin theta by theta less than 1. Now applying limit as theta tends to 0 throughout this equation, I will get limit theta tends to 0 cos theta less than limit theta tends to 0 sin theta divided by theta less than limit theta tends to 0 1. Now if you apply theta tends to 0 here, cos theta becomes cos 0 is 1. Again here keep the limit as it is, theta tends to 0 sin theta by theta. If you apply the limit for a constant, it is constant itself. Now here the left hand side function as well as the right hand side function of the function sin theta by theta value is same. Hence I can conclude limit of theta tends to 0 sin theta by theta is equal to 1. So I got the result. So this is possible whenever theta lies in the first quadrant. That is, if theta is positive, then the result is true. Now what happens if theta is negative? If theta is negative, then limit as theta tends to 0. So sine of minus theta divided by minus theta we have to take. Now let's see limit theta tends to 0. What is sine of minus theta? It is minus sine theta and divided by minus theta. Since we have minus, we can remove it. Now this is again in the form of limit theta tends to 0 sin theta by theta is equal to 1. Hence the value is equal to 1. So whether theta is positive or negative, in both the cases we can conclude that limit of the function sin theta by theta as theta tends to 0 is equal to 1. So this is how we prove. So first we have to take a unit circle with small construction, explain the construction with the statements. Then by the figure you can write area of the triangle is less than area of sector. Again it is less than the area of the larger triangle. Applying the formulas we will get equation 1. Then solving and putting the values of BC and AD using trigonometric ratios, we will get the relation. Take the relation in the form of a sin theta less than tan theta, then divide the equation by sin theta, take the reciprocal, apply the limit, you will get the answer for positive angle. Suppose theta is negative, then also you will get the same answer. Hence we can conclude limit of the function sin theta by theta is equal to 1. The last two questions you can expect for 5 or 6 marks question in your examination, which is very, very important. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.